Alright, welcome. Today we'll be talking about conditional probability. Now the conditional probability of event B in relation to event A is that the probability that event B will occur given the knowledge that the event A has already occurred. Okay, now to just give some plain English definition on that, I'm going to cite regentsprep.org as a great layman term of what that means. Okay, let's say you toss two pennies. The first penny shows heads and the other penny rolls under the table and you cannot see it. Now, what is the probability that they're both heads? Since you already know that one is heads, the probability of getting heads on the second penny is 1 out of 2. The probability changes if you have partial information, and the affected probability is called the conditional probability. Okay? All right, and that notation is given by this formula right here. It's got the absolute value sign right in between the B and the A. Okay, now how this actually reads is this. Okay, so probability of B given A is the probability of event B happening given that A has already happened. Okay, so that's what that means right there. Alright, now if the two events are independent, the probability of B happening given that A has happened is just the probability of B. So that's pretty simple. Okay, however, if they are dependent, okay, the probability of B happening given A is equal to the probability of A and B divided by the probability of A. Okay. Now, also a corollary of that is you can use the formula for the probability of A and B is equal to the probability of A times the probability of B given A. Okay, and it's just a simple reworking of this formula up here. Okay, so let's go practice this stuff. Okay, so a bag contains 12 red M&Ms, 12 blue M&Ms, and 12 green M&Ms. What is the probability of drawing 2 M&Ms of the same color in a row? Okay, so this is definitely going to be a conditional type of probability right here. Okay, so conditional, okay, probability that we've already drawn a blue M&M, okay, and given that the first M&M is blue. Okay. All right. So what we do is we just find the two formulas. So the probability of blue and blue. Okay. So the first one is going to be 12 out of 36 times 11 out of 36. Okay. So that's going to be that probability. And the probability of just A happening is 12 out of 36. Or just one blue happening. The first blue. Okay. Alright, now if you notice there's some similar fractions on there, but the formula is actually set up to be like this, to where we take the 12 out of 36 then we times it by the 11 out of 35 because there's only 35 left. Okay, and you have to remember this is definitely going to be a dependent type of problem because the probabilities do affect one another. Okay, and so this one is all going to be over 12 out of 36. Okay, now the reason why I'm not multiplying the top two is because if I see on the bottom I'm dividing by a fraction. So if I turn around and flip it and just multiply by 36 out of 12, okay, all right, now when I do that, this doesn't exist anymore. Okay, now when I do that, if you notice there's going to be a 36 in the denominator and a 36 in the numerator, so that's going to cancel out to ones. That's going to simplify to ones, and same thing here with the 12s. Okay, so I'm left with a bunch of ones. Well, guess what? What's left is 11 out of 35. Voila. I actually have it. It's all set. Okay. Now on to the next problem. Okay, so in a school of 1,200 students, 250 are seniors, 150 take math, and 40 students are seniors and also take math. What is the probability the randomly chosen student who is a senior is taking math? Now, this one is going to be worded, it's not the best wording in the world, but it gives a hint as to what's happening. So if you notice before the comma, who is a senior, so this is almost like saying this is given. Okay, so we're given a senior. Okay. Alright, so that's interesting right there. And they're taking math. So this is almost like the event B, and this is A that's given A. Okay? Right? So when we set up to find this probability is going to be probability that the student is taking math given that they're a senior. Okay, so that's a good way to set it up. So in order to do this, we need to find the probability that it is a math and a senior. Okay, and the probability of it just being a senior. Okay, and so let's calculate that. Okay, so it's going to be 40 over 1,200 and 250 over 1,200. Okay. Alright, so we set up our problem. So on the top it is going to be 40 divided by 1,200, and on the bottom it is going to be 250 divided by 1,200. Okay. Alright, now if you notice, I have a fraction being divided by a fraction. Okay, so I need to multiply the top by the reciprocal. So it's going to be equal to 40 over 1,200 times 1,200 divided by 250. Okay, now if you notice, I'm going to have some like factors in the numerator and denominator, so those simplify to ones. What am I left with? I'm left with actually 40 divided by 250. Okay, which turns into about 0.16, which is equal to 16% chance that we're getting that we're going to randomly choose a student who is a senior. They're given. We're going to be choosing a senior from the senior class, and we're going to see what the probability is choosing him at taking math. Okay, all right. So looking for these commas are hugely important because the word before the comma is going to be your given A, and the stuff after the comma is going to be your B. Okay, so that you can set it up correctly. Okay. All right. Now that is it for working with conditional probability. You're going to find a lot of problems. Please feel free to contact me. I'll talk to you later. Bye.